All right, so good morning, everyone. Thank you for joining us again this month. My name's Rob Sedor. For those who haven't joined before, I'm an architect at Red Hat in the office of the CTO. Normally, I have a colleague. My name's Rob Sedor. For those who haven't joined before, I'm an architect at Red Hat in the office of the CTO. Wow. Normally, all right, so now you got to hear it twice. So maybe John can help us out with that later. Again, thank you for joining us today. My normal comrade in arms or colleague that joins us is Jeremy Davis. He's also an architect at Red Hat. And today he's doing one of those parental things. I believe he's going to visit colleges. So that should be exciting for him. We'll query him on that next month. And in the meantime, Philip Hayes has been kind enough to join us this month to talk about Quarkus, Azure, Skupper, and Backstage, and tell us what all those words mean, because I'm sure a lot of you, don't know yet or are interested. So Philip, why don't you tell us a little bit about yourself, and then you can feel free to jump right in.
Thanks, Rob. So my name's Philip Hayes. So I'm part of the runtimes team within Red Hat. So I focus on Java development, app modernization, EAP, those kind of things. So recently I've been looking at a couple of the new sort of technologies coming out. One of the ones that came out from Azure towards the sort of middle to end of last year. They had an incubator project called Radius, which they kind of open source. So I took a look at that and built a sort of a proof of concept using some of Red Hat's cloud native technology, specifically Quarkus for Java development, and also Skupper and Backstage as well, which are the upstream products for some of the products that Red Hat have recently released and provide support for. So let's just let me kick off. We'll go through and just give a kind of a brief introduction to what each of these different technologies is. So as I mentioned, Azure Radius, it's an open source project that supports deploying applications across public and private clouds. I would encourage you to have a look at radapp.io. There's some good documentation there, and getting started guides around Radius. But I mean, the idea is that it kind of allows developers and operations teams to have very clear sort of separation of concern. So developers can focus on developing, obviously the application logic, focus on their code, and then when it comes to deployment, operations teams can make sure that developers have the ability to deploy to whichever environments they need to, without having to sort of get into the weeds of how to connect into Azure, how to sort of set up resource in Azure, for example, or on AWS, or if they're looking to develop locally, maybe a local Kubernetes cluster that they have available. So we'll see in the presentation how I can create a simple sort of Radius app that will allow me to deploy to a development environment, which is in my case an OpenShift cluster, and then if I push that out to production, it will start to create resources on Azure and so on. But again, without really anything that I need to do from the development perspective. So it's pretty cool. It's very early days though. It's like on version 0.30 as of today. So it's very much sort of alpha type technology. It wouldn't be necessarily production ready at this point, but worth a look. Backstage, there's been a lot of buzz around Backstage over the last couple of years since it came out from Spotify. It's a product that Red Hat have a productized version of Backstage now in Developer Hub, and with that there is support for plugins to Red Hat technologies such as the topology view for Kubernetes and OpenShift and Quay, Argo CD plugins, those kind of things. But Backstage, it's a lot. It provides like quite a broad sort of offering. The idea being that it's an IDP for developers to be able to, self-serve, start new projects, get insights to existing projects, look at how, where they're running, look at the, any images that have been created as a result of them, where the documentation is, look at various different environments, look at the logs, sort of a kind of a one-stop shop to be able to spin up or look at projects from a development perspective, without, again, having to sort of go through all the hoops of getting access to various different systems and all that kind of stuff. So we're going to use Backstage today to create this Radius project, which ultimately then will allow us to use these other technologies. So Skupper, for anyone who doesn't know about Skupper, it's layer 7 service interconnect. So it allows secure communication across Kubernetes clusters, or back to virtual machines or bare metal with no VPN or firewall rules. So what we're going to use it for today is quite a simplistic sort of example of how to use Skupper. It's a lot more, it has a lot more capabilities than we're going to go through today. What we're going to use it for today is to enable communication from a virtual machine to a container running in OpenShift without having to open up any firewalls or anything on that virtual machine. And it's going to be all done using mutual TLS and everything, all that kind of set up for us by the Skupper CLI. Again, it's a framework that Red Hat have a productized version of. So Red Hat Service Interconnect is our sort of supported version of Skupper, which is in the market now. And then I'm going to use Quarkus. I would hope people on this call have heard a lot about Quarkus over the last few years. It's ideal for cloud native Kubernetes native Java development, providing very fast boot time, very small footprint. And we're going to use Quarkus just as a very simple application that's going to use a Postgres database and a Redis cache, as an in-memory cache. And again, we're going to spin that up using our Backstage template that we have created. I'm not going to go into a huge amount of detail on Quarkus. We'll just sort of see how it's used in this example. So again, what we're going to do is we're going to spin up a project using Backstage, cloud native development project that is going to have a Radius template, which is going to allow us to deploy our application to different environments based on whether we're going to dev or prod, or etc. Within that, there'll be a Quarkus application that'll be the core of the project that's spun up, and we're going to use Skupper then to retain connectivity back to any sort of potentially any legacy in-house systems. So let's look at the sort of, this is the kind of architecture that we're sort of starting off with, right? So so hypothetically, we've got an OpenShift cluster, which maybe could be in an in-house data center, and this is the cluster that our developers would use to try out applications and do development testing and so on there. So the developer would have the ability to spin up resources on this development cluster, maybe spin up databases, caches, that kind of thing. We also have a prod cluster as well, which could be running on the cloud provider. In this case, it's Azure. It could be AWS or any other cloud provider as well. And we have 2 virtual machines, both with a database running in them. I'm using a database in this example, but it could be any sort of legacy service as well. It could be a SOAP service. It could be anything that we could access really over HTTP. To connect back into that system. And it's quite a sort of a common scenario that as you start to migrate applications to the cloud, you may have some services which have other dependents within the organization that can't yet be moved to the cloud. So using something like Skupper or Red Hat Service Interconnect is an ideal way to leave that service in place, but be able to sort of open connectivity from your cloud services back into that. So that's what we're going to do to start off with. We're going to use Skupper to create a connection between our namespace and our dev cluster back into our database running on our virtual machine. I've already got this one connected up just to save time in the demo, but we'll go through the setup of this one. Once that's in place, we're then going to go to our Backstage front end, and we're going to spin up a new project which will have Radius and Quarkus. It'll use a Radius template to deploy a Quarkus application that uses a Redis cache and connects via Skupper back to this database. And the cool thing then about the Radius framework then is, again, as a developer, all I need to do is specify we need a Redis cache for this application. Radius will look after where that Redis cache is deployed, whether it's deployed locally for dev purposes or whether it's deployed on Azure, maybe for QA or production sort of purposes. And it looks after the connectivity between these, via secrets in Kubernetes or OpenShift. So it does a lot of the heavy lifting around the sort of deployment of these dependencies and wiring them all up for us. So let's have a look at the demo. Hopefully everything goes well. I mean, there's a few moving parts here, so fingers crossed everything goes to plan. So let's have a look at what we're going to go through. We're going to use Skupper to connect a database on our private data center in dev and prod environments, right? So I have I've got some instructions here. So let me go through and see. So I'm going to create a new project on my OpenShift cluster, right? So hopefully everyone can see my screen. The font is big enough. Let me try that again with the actual proper command. All right, so there's my new project created, and now I'm going to use the Skupper command line interface to do the work for us here. There are also Skupper operators and so on that can be used to deploy on OpenShift. There's a number of different ways that we can use Skupper to do this. I'm going to do everything through the CLI. So let's first of all deploy Skupper in our namespace, right? So let's just deploy that. And you can see here, I've got the enable console flag enabled, and I'm telling it that I'm using OpenShift as the authentication. So if we go back to our UI here and go to dev radius, you can see we have a few routes created. We've got some pods running. There's our Skupper pods running there, and we've got a route here I should be able to access. If I go to there, and it used OpenShift there to log in. So there's my Skupper console, and you can see there's my namespace set up. So we don't have any services, we don't have any virtual machines or anything hooked up to that. It's just literally deployed within my namespace. So what we're going to do is we're now going to create a Skupper service, a database service, listening on port 5432, which is the default port for Postgres. Let me just hide this here. All right, so that's that service created, and I'm now going to create a bundle which is going to provide all of the sort of mutual TLS certificates and everything that's needed, and all the sort of the route information that's going to be needed to be able to connect back to this Skupper instance on my OpenShift cluster, right? So let me just run this command, and we'll leave that to do its work.
Hey, all Philip, right, so can you just make the font just a little bit bigger?
Yeah, sure. Yeah, how's that? Is that better?
Yeah, great. These old eyes we're having a hard time here.
Yeah, no problem. All right, so I've created that bundle. I'm now going to copy that to my dev VM, right? So you can see here, that's my, my environment variable there for my dev VM, just to make it simpler. So let's just copy that over. Oh, I haven't. I got rid of my environment variable. Let me just copy that now. That's the first thing that's gone wrong. Let's just see. Okay, so let me just copy that over then. So that's copied that onto the dev VM for me, and now I can SSH into there, and I can now start to do what I need to do on my dev VM. So I've already created my gateway previously. So now, I copied over this this package here, this tar file. I'm going to basically expand that, and I'm now going to run my Skupper service now on my dev system, right? So let's just run that. So that's running, and let's go back to the Skupper console again. And if I just go here, back to the topology, let's just give that a second. There we go. So we can see here now we have a link created between our namespace in OpenShift and a database service running on the virtual machine. So, and again, I've done that by just running something on the virtual machine, not having opened up any firewalls or any ports or anything on the virtual machine. It's making an outbound connection back into our route that's exposed on OpenShift. It's using mutual TLS, and the only thing it's enabling connectivity for is that Postgres database listening on port 5432. So there's no way that you can kind of get into this network and browse the network. It's literally just that one connection back into that database. So that's connected up. So now I've done that, I could now use Backstage to create our Quarkus project that uses Radius. So in my Backstage UI here, this is just the sort of vanilla Backstage interface. I can create a new service, and I've got one set up here, Quarkus with the Radius template that uses a Postgres database and Redis. So let me just select that, and we'll give it a name. Let's just call it Corner. We'll call it the image name of Corner as well. And I have my own org in Quay, so I'm going to use that. And again, I've got my own, and then we'll just call that Corner as well. Okay, so basically what I'm doing here is I'm giving details of a GitHub repo that I'm going to use. It's going to be in my own account, and it's going to be called Corner. And I've done the same with the image as well. It's going to be in quay.io, and that's also going to be called Corner. So let's just see what happens when I go through that. Okay, so that's publishing that. So if I look at the repository, we should see this has just been created first now in my GitHub account. And you can see here, this is the Quarkus demo and so on that we want to be able to deploy to our various different environments. Again, that's all been done for me by Backstage. I didn't need to know anything about the connectivity to GitHub and Quay. It did all that stuff for us. All that sort of wired up under the hood. All I need to do now as a developer is just check this out. So let's check out this code. Type. There we go. Let's go into here. All right, so just get rid of that. Now I'm going to update my font size a bit as well. Okay, so if we look at the README here, actually I can scroll down to the end here because I've just got some default stuff. So just bear with me 1 second. Okay, so here we go. So here we have instructions now to build this image and push it to quay.io. So again, from a Java development perspective, it's fairly simple. I just do a normal Maven package. That should take a couple of seconds to compile that artifact first. Okay, and once that's done, we can then do a build and push that to Quay. So, and you can see here again, because I named the image Corner, all of that's been defined for us as part of that Backstage build that was all set for us. So I now have the commands here that I can use to build and push this image to Quake. So let me just do a build. That's pretty quick, and now I can push that to Quake. So let's do that. Okay, so that's pushed there. So let's have a look at Quake interface here, and there's my repository. There's the build that was just pushed up there by us. All right, so that's all done. Again, very simple. I didn't have to do any configuration there. Backstage has set all that kind of stuff up for us. So now that that's been built, I can now start to look at using Radius to deploy this application for us, right? So, and you'll see here that within my code, I have a Radius folder and I have a bicep file. And if we look at this bicep file, this is the Radius sort of instructions. It's telling us the image that we're going to deploy. Excuse me, let's get rid of that. Again, that's all configured for us, pulling it from the proper repository in the image library there. And also, we're telling it to use a Redis database as well. But you'll see here, we're not specifying where that Redis database is going to be. We're just saying, when we deploy this project, we're going to deploy this image and also a Redis database. And it's going to look after doing all those connections and everything for us, right? You'll also see here, just if we look at the resources, we've also got, we're telling it that we're going to use a database called PostgreSQL, and we're calling the database Wildfly. That's the connection that has been enabled for us via Skupper. I don't need to change any of this because it's always going to be using a service called PostgreSQL from the Kubernetes point of view. So hopefully that makes sense. So let's go and see then what we need to do to deploy this. So let's go into Radius, and we're going to now tell it to deploy this to our development environment, right? So you can see here, this is the environment we're deploying to. Right, so give that a second. So first of all, what it should do first of all is spin up a Redis cache for us in our dev environment. So let's go back to OpenShift, see what's going on there. Okay, there's our Redis cache that's been spun up, and actually there's our Quarkus application running as well, right? And if we look at the logs in our Quarkus application, we should see, oh yeah, we've got a couple of database keys already exist there, but it is able to connect to our database. That's actually even.
Can you make that a little bigger?
Yeah, of course, yeah. Back here. Actually, that one just terminated. I'm just getting that should spin up again. There we go. It's ready now. So yeah, so you can see here it is connected to the database because it's coming up with errors here that these tables already exist. So that's fair enough. And again, we can see that it created this Redis cache for us as well. So again, pretty straightforward from a developer's perspective. Don't have to worry about setting any of those kind of things up. Actually, if I go to our secrets here, we should see there's all the connectivity information to our Redis instance from our application, right? So the final thing we should be able to do there then is we should be able to expose. Actually, that's an error there in that, but I'll fix that. Our application is called Corner. So there you go. So that's that exposed. Again, if we go back to our UI here, there's our Quarkus application that we're able to access now, and I can start to store data there. Oh, there you go. The demo gods. There you go. There, it stored it for us. So we have a Quarkus application which is running. It's able to connect to the cache running locally in our Kubernetes cluster, and is able to connect to a database that's running on a virtual machine via the Skupper interface. So we're kind of at this point here now is all in place, right? And we were able to do that very easily using this Redis, this Radius tool.
So just to review real quick, Philip, the Backstage thing is really about, we have a new developer in the company. We want to onboard them quickly. There's data out there showing that it could be anywhere from 2 weeks to 2 months for a new developer to onboard properly.
Yeah.
They can quickly come up to speed and see everything that's going on and be connected to the environments.
Yeah.
And the source of truth is really, what you're looking at in the code versus, a wiki page that is probably out of date and not very well maintained by the development team, right? So
yeah, exactly. Yeah.
And then Radius is assisting us in the background by doing some of the connectivity there, right?
Yeah, effectively, yeah. I mean, we're really scratching the surface of Backstage, and you can just see, for example, one of the things that I have in this instance is I have the Quay plugin, so we can see, again, within this interface, without having to log into Quay, I can see there's my image that's being pushed up, and there's a security scan in progress there. But if I wanted to, I could also have the Kubernetes plugin here, and I could actually see this application running on my, in my OpenShift namespace. I could have an Argo CD plugin, so I could start to see, sort of CI/CD sort of process as well. So yeah, back to your point, as a new developer joining an organization, first of all, you can get up to speed really quickly. Like you're talking in, a matter of, hours rather than weeks or months. But you can do that in a way that's been very much controlled by the organization to ensure that anything that you do push out even to the lower environments is going through the correct security checks, image scans. You've got all the right guardrails and everything in place to make sure that you're doing what you're allowed to do in a controlled fashion. So but as I said, what we're doing here is quite a simple example of that.
And Skupper is this beautiful thing that allows us to connect through the application layer, layer 7 on the network stack, so that we can avoid having to deal with all the other networking issues, opening ports in the firewall and doing all that good jazz that we previously had to do. So we're kind of removing a lot of friction here. So we're removing friction for the developer to have to deal with things, internally, because they can come on board pretty quickly. We're removing the friction of having to go and, talk to various networking people and everything, but we have MTLS. We have the ability to do multiple, HTTP 1.1, gRPC and different ways to connect things together so that database or different Kubernetes clusters, et cetera, without having to go through a bunch of gyrations, and it just does it across the existing route, right? Or ingress.
Yeah, absolutely. Yeah. And again, as I said, the example I'm giving here is a very simple version. The Skupper is a lot more flexible. You can have sort of multiple instances within an organization. You could potentially have one in a DMZ, which is a sort of the one that does the connections to outbound routes, and then that connects back into sort of systems within the organization. There's lots of different ways to deploy it. It's very, very powerful and flexible. So let me just while that's deploying there, or actually being deployed, what I'm going to do is back in my application, I now want to deploy this to pod. So again, I'm going to use the same command that I used to deploy to dev. Let me just close that port forward there. But this time you can see I'm telling it to deploy to the production environment. Now, in reality, a developer probably isn't going to deploy it to a production environment from their command line. But you could see, I could be deploying to a test environment. I could be deploying to, a QA environment or something. And again, from my perspective as a developer, I don't know anything about where my cache is going to be created. Skupper is still in play here because it's creating the connection back to my virtual machine, but in this case, my production virtual machine. But you'll see here now that it's creating a Redis cache. And if I now go into Azure and just refresh my resources page here. Let me just see where's the refresh button. Yeah, so there's a cache that's being created in Azure for me now. So if we look back at our prod instance here, you can see that it's deploying the application first, but it hasn't. It's not deployed an instance of the cache in this namespace. So the cache it's using is on Azure. And actually, I don't think the secret is there yet, is it? Let me just see. The secret. What have we got here? Yeah, there you go. So there's our connection and connectivity back to our Redis interface on Azure. That's been populated and everything for me within the namespace where my Quarkus application is running. So again, as you know, and the nice thing there is, as a developer, you know, it's deploying this here, but you know, I don't have to have any you know, configuration and so on set up in order to be able to do that. That's all done by the operations team and also the manage for them there. So, but now this deployment generally takes about sort of 10 minutes or so for this cache to be set up on Azure and ready to use. So we'll probably run out of time before we can actually go over and have a look at that. But we'll leave that running in the background there anyway. So yeah, so that's kind of what we've achieved. So we've sort of gone through everything. We've set up our you know, our Skupper interface back to our virtual machines in both prod and dev environments. We've got connections to our different namespaces, whether they're running on prod clusters on OpenShift or dev. And then we've deployed Redis instances as well. But the deployment of that is being managed by Radius based on how the operations team would have configured those particular environments. And again, the connectivity between those Redis instances and the application has all been managed by Radius using secrets within the namespace. So yeah, so that's what we wanted to go through. Is there any questions in the chat or anything, Rob?
No, I don't see any right now, but is there? So we just to rehash, we kind of reviewed, you know, what Skupper does, Backstage, which is, you know, you're using the upstream version of everything. Radius, you know, one question is, you know, Radius uses the bicep files, which is a very Azure specific format, right? Does it support Terraform or anything like that?
I think it does. Let me just see if I look at the Radius docs, right? It's a good question. There is another format as well that it can use.
I know it does like an ARM JSON format or something like that, or you can switch that in and out.
Yeah. There's a bicep version there. It does use. I can't remember off the top of my head now the other version, so I'd have to look into that. But it is, you know, it is an Azure. It is a Microsoft, you know, offering, right? But they are sort of trying to do it to be open. You know, the idea is to create portable applications. So they're providing you know, support for AWS currently. So you could, everything I've just done here, we could also do in AWS as well. So I think the idea is that, again, is to try and make it as sort of platform agnostic as they can. But ultimately, it is using Microsoft technology. So that's, you know, hence the bicep files in that regard. So.
Now, one of the things you did was the production databases in a VM on prem, right?
Yeah.
Not on the cloud.
Yeah. So and both of them are. I mean, both the dev and the prod one are. Yeah. So I have two different VMs just spun up here. So that's the idea. And again, it's you know, we're using a Postgres database here, but again, don't, you know, this isn't just for database connectivity. It's really for anything that you want to be able to connect to across HTTP. It could be, a soap service, it could be some sort of legacy application that can't be moved to the cloud, but you still need connectivity, back from something that you deployed in the cloud. So it's ideal really to sort of start to work on migration in a phased approach, which is really the only way to migrate, applications from in-house data centers to the cloud, so.
Now, after you set everything up, are all the artifacts now in Git?
The code, yeah. So the code is in Git. So Backstage did that first. It pushed that code first to Git. So that's all there. And obviously, if I make any changes to the code, all those updates will go up. When I created the image, that was pushed up to Quay first. So you can see that's pushed up there as well into this Quay repository. Any sort of image repository would work as well. That's configured on Backstage. So yeah, I mean, it's whatever the idea again behind Backstage is to use plugins and create connections to whatever sort of systems you use internally. Whether it's documentation or image image repositories, code repositories, all that connectivity should be done, allowing a developer just to basically add their own sort of keys to the system and start working and pushing and deploying code.
Now, how would you recommend manage? So you did a lot of command line stuff that I mean, it's great that you copied and pasted that in, but how do I keep track of all that? Is that going to, I mean?
Yeah, I mean, so there's a few things really, right? So I started off, I went through the Skupper connections, right? And I used the Skupper CLI to do that. Now that can all be automated. You can use the operator to deploy Skupper on OpenShift. You could use Ansible, for example, to make any updates you need to on the VM. So everything that you would do through the command line in that regard, you would certainly look to automate and use infrastructure as code in order to do that. I then spun up an application in Backstage, and that gave me my code in a Git repository, which I cloned locally, and I used some commands then to push all that code out to Kubernetes and to Azure. But again, all of that would be done through pipelines as well. So the expectation would be that I pull out my code locally, I push a change, that will then trigger a pipeline which will create my image, push it to Quay or whatever image repository I use. And it would use Radius as well as part of that CI/CD process to spin up any resources that are needed, like the Radius cache, for example, join up the dots and deploy my image from the image repository. So yeah, as with everything that we kind of we talk about, it's all done in a kind of a cloud native way. So everything should be, you can describe it using YAML, you can build it into pipelines, and store it as infrastructure as code if needed.
Okay, so I mean, just boiling that down, I could just create a bunch of Jinja templates and take all your Bash scripts and put them in there.
Yeah, you could do. I mean, you probably wouldn't use, so the Bash scripts I used, again, for the Skupper stuff, you would use the operator, right? So that you would then deploy that maybe with Argo CD to, keep your namespaces up to date with whatever resources need to be deployed. So, and you would store that in Git. So you would create the YAML around deploying Skupper, store it in Git, and then use something like Argo CD then to ensure that's all in place on the namespaces. The work that needs to be done on the VM, I would personally use Ansible or something like that to make those changes to deploy the the Skupper interface on the VM. And then from the code perspective, again, that's Git, and it's Git, connecting into pipelines that create the image, and all the Radius stuff. That there's CI/CD sort of techniques to do everything I did there through the command line as well. So you would do all that through pipelines.
Cool. All right.
Yeah.
So I don't see any questions online right this moment. If there are questions that pop up for anybody later on, our contact information will be provided in the probably in the YouTube video or online. I believe we provide that every month. So, Philip, any parting commentary that you'd like to say? If you had to do this, yourself actually for real and not just a demo, what would your thoughts be around that?
Yeah, I mean, I think that again, there's a few sides to it, really, and it's about sort of having the separation of concerns between the developer and the operations team. So, the operations teams would be very heavily involved in the configuration and the setup of Backstage, right? That's the critical thing, and that's not a trivial piece of work, right? It's going to take some time to get Backstage, configured with the plugins and everything, so that when a developer then is onboarded, the load on them being able to sort of get started is reduced. They can basically spin up a new project, and they can start focusing on the business logic and starting to push code and contribute as quickly as possible. So the work for the operations team really is on that Backstage configuration. And if they're going to use a tool like Radius or something like that, again, it's about spending the time to get the different environments configured. So when developers then want to deploy to dev, they can do that. If they want to deploy to a higher environment, they can do that. But the operation team has controls of what resources have been deployed. So to answer your question, I think if I was to do this in the real world, I think it's work that has to happen in conjunction with the operations team, and also done in such a way that there's kind of an infrastructure as code sort of approach as well. So again, so when we come to configure things like Skupper and so on, that's all done through YAML, through Git, through things like Argo CD, to ensure that everything is sort of is tracked and source control from that perspective. So yeah, so that would be my approach to it.
So I mean, I keep hearing this term, cognitive load all the time.
Yeah.
It's kind of a catchphrase nowadays for a lot of things. For me, as a developer, you're in your IDE or you're in NeoVim or whatever tool you're using to write code in. I'm probably using some SQL. I'm probably using YAML. For God's sakes, I hate YAML, but JSON. There's the language you're writing it in. Half a dozen other tools that you're using at the command line. There's just so much stuff that has to float around in your head that you have to keep track of nowadays. Some things are making it easier. GitHub Copilot, that makes life a little easier. When you can have a plugin that just continues your line, but then you have to verify that it's actually good code. Blah blah blah.
Yeah.
And on top of that, you're writing documentation because the test folks want to see what you did, and they want a summary of everything. So I probably have a tool for that. All that overhead now is on a developer, and I think what you just described to us was having the infrastructure folks assist in a kind of platform engineering aspect of things to reduce the overhead of having to know all the other stuff that's going on behind the scenes, so I can come up to speed quicker and just dig into what I'm supposed to be getting paid for, which is to write code, right?
Yeah. Absolutely, and it's even more, apparent when you start to look at, the cloud provider, so AWS, Azure, the amount of cognitive load for developers to understand how to build, serverless applications in AWS, using Kinesis streams or, DynamoDB, all of these kind of things. The reality is that's the sort of stuff they need to know, right? Because it's important for them to do their job. But the actual sort of provisioning of that, and ensuring that they're secure and locked down, and that the guardrails and so on in place. That's stuff that they need to be aware of, but really the operations team, through the use of things like Backstage and that kind of stuff, should be able to take that load. So developers can then, as you say, focus on doing the job at hand, implementing the logic, getting their code pushed out to production, using all of those sort of cloud techniques and everything that they know about. But it's there's more to being a cloud developer than just understanding how to develop on the cloud. It's and a lot of the sort of the management of that can be taken away from them. They shouldn't need to worry about it by using these kind of platforms, I think is the key. So
yeah, I mean my dream state used to be we're at the end of the sprint, we're doing the retrospective, and while the retrospective is going on, we're actually setting up for the next sprint. We're creating the branches for everyone on the team, off the feature branch, and everything's going on, and all that environment is automated and all being set up so that we can start developing right away on the next sprint.
Yeah.
And to various degrees, we've gotten there, and to various degrees, we keep failing to get there. And there's still a whole bunch of overhead, in between the sprints in order to make that happen. And then, there's always the arguments about, well, my production looks different than my dev environment, and that looks different than my test environment. And so while containerization has helped us make sure that the code is packaged in such a way that it's the same across dev and test and prod, all the other stuff behind it isn't always the same, or isn't fully automated yet in different environments. And different organizations are more mature on that than other organizations. So I think what you're describing is kind of a really that would be kind of the goal state. And
yep.
Backstage, Skupper, Radius, all these tools together kind of remove all that cruft, if you will, that I have to think about as a developer, and I could just jump in and start developing again on the next sprint, right? Makes a lot of sense to me. I'm glad that you came and demoed all this for us. For those online, I've actually seen Philip demo this before, which is why we wanted him to come and talk about this, because he makes it look so easy. But there's a lot of work and setup, like he said, in order to get this set up to make it look easy, but it reduces that cognitive load for the developers, which is
and it's a good point. There is a lot of setup, but it's setup that the developer doesn't need to necessarily do, right? That you saw really, you could kind of, maybe if I do this demo again, you have a couple of different hats where really, as the developer, pretty much all I had to do was go into Backstage, create my new app, and then everything was there in the README for what I need to do in order to deploy that to a dev environment. So that's the real, that's the real crux of it. Setup and sort of, getting all those sort of things figured out and wired up is something that, could potentially take time, but it's time that doesn't need to be, duplicated when you add on new resources. It's all done, and that, again, developers can then reap the benefits of that and start to be productive,
No, that's great. Well, thank you, Philip, for joining us this month. I really appreciate it. I enjoy watching you do that demo, because I probably would have screwed it up 10 ways to Sunday. But the idea behind all this is, making the developer more productive and our teams more productive, which I think everybody wants that. So anybody that needs to reach out to us with any questions, our contact information will be made available. And I appreciate everyone for joining this month. So again, thank you, Philip.
Yeah, thanks, Rob.